So today in this video, we'll be seeing about how the residential wiring with a small demo example. So in this circuit, we'll be having huge electric meter, MCBs, and loads, etc. Could anyone please explain the use of fuse and MCB in this particular residential wiring?
Yes, ma'am. In our daily life, electrical safety is very important. Sometimes excess current flow through due to overload or short circuit. So that may damage our appliance and also cause fire accidents. That's why we are using protective device like fuse and MCD. First of all, fuse is a safety device which contains a thin metal wire which melts and breaks the circuit when an excess current flows through it. It cannot be used again and again. We have to reuse it once it's break. Next, MCB. MCB stands for Miniature Circuit Breaker. MCB is an automatic safety device which automatically trip the switch when it detects short circuit or any current leakage. So it can be reset and it's also used again and again. So the main difference between fuse and MCB are fuse can be only used once and MCD can be reused. So that's why MCD is mostly used in our residential wiring.
So as Ajay has explained, so miniature circuit breaker is being used for residential wiring and fuse is being used between the energy meter and the transmission line. So fuse is used for single usage and miniature can be used again and again. So could anyone explain how the energy meter will be working, how it can be used for calculating power, etc.?
Yes, ma'am. This device is an energy meter, also known as watt meter, used to calculate the amount of current in household buildings. And it is meter shown as a single phase AC meter, typically used for measuring current in residential house. Working principle, this meter works on the principle of measuring electricity in kilowatt hour. The rotating mechanism inside the meter measures the amount of current. The reading displayed in the above of the meter, the total usage is 1 kilowatt is equal to 1 watt.
So, as we told, the energy meter is being used for measuring the power consumed by particular region. So, in an energy meter, the calculating the power which has been used by our residential. So, this in the circuit diagram, it shows a simple residential connection. So, could anyone explain the working of this particular circuit and also the working principle behind this?
This is house wiring demonstration board, bulb switches, MCBs, and energy meter. First, main supply is connected to the power. The power enters the system from the main supply. Energy meter, the supply first passes through the meter to measure the electricity consumption. MCB, power then goes to the MCB, which protects the circuit from the overload and short circuit. Phase wiring, the phase wire is distributed to the different switches on the switchboard. If we on one switch, it will go to the energy meter. It will measure reading slowly. If you add on one more switch, it will measure reading fastly. The neutral wire is directly connected to the bulb without switching, lamp holder and bulb. The lamp holder fixed in the holder and act as a load to demonstrate lighting circuit. Pipe wiring. The wiring is the routed through the PVC pipes from protect and proper arrangement. Operations. When the switch is turned on, the circuit is completely current flows and the respective bulb glows.
So when, as he explained, and switches on, the respective wire connection is actually given to the bulb, it start glowing. Here we have used 300 watts bulb. Based on the load we are using, the speed of the energy meter will start rotating. And when anything happens in this particular circuit, like short circuit or any unattended wire due to that any problem, then MCB will automatically shut down its working so that the current flow is stopped to our switch box. Okay, now we have seen the working. So, anyone could explain the precautionary steps which need to be taken in case of residential wiring?
Today I will talk about the precaution in residential wiring. Electricity is useful but can be dangerous. So we must be very careful. First, always switch off the main power before touching any wires. Never touch switches with the hands as it can cause electric shocks. All wires should be properly insulated and the damaged wires must be replaced quickly. We should also avoid overloading shocks to prevent overheating and fire. Using good quality switches and safety devices like fuse or MCBs is important. If there is any problem,
So, in this case study, you would have understood how the wiring should be done for the case of a residential in this miniature model, and what is the use of fuse and the NCBs, and how the electric meter is being used for taking the reading of and the power consumed, and also the why the proper precautionary measures should be taken, how the wiring materials or the plastic materials which are being used for the lamp holders, switches, switch boxes, and wires quality are way more important since these also contribute the safety measures. Apart from that, this is a miniature circuit. The same should be applicable for all the residential building wiring.